Hello students, this is Ravikant, the physics teacher. Hope you all are doing well. Today we are going to discuss BPT 25 question paper. Right, so let's begin with it. So the very first question it says is that when aluminium is bombarded with fast moving neutron, it changes into sodium with emission of particle X according to equation. This is the equation which is given, and the particle X is. So to solve this question, we'll have the concept of that the atomic number, the sum of all the atomic number on the the reactant side is equal to sum of the atomic number on the product side. Similarly, the mass number on the reactant side should be equal to the mass number on the product side. So if you see the mass number on the reactant side is 27 plus 1 is 28, but on the reactant it is 24. So to make it 28, the mass number of X should be equals to 4, right? And coming to the atomic number, it is 13. Here it is 11, so it should be 2. So what we get X as X is equals to mass number as 4 and atomic number as 2. It is nothing but a alpha particle. So the correct answer for question number 1 is option 3, that is alpha particle, right? Now coming to question number 2, select the correct statement. First statement says the particle at rest breaks into two particles of different masses. They fly off in different directions. Their de Broglie wavelength will be different. No, their de Broglie wavelength will be same. Why same? Because when they break in two different masses, but initially it was at rest, so the momentum gained by the two particles will be equal in magnitude, right? Will be equal in magnitude, and de Broglie wavelength is inversely proportional to the momentum of the particle. Therefore, since both the particles are having the same momentum, the de Broglie wavelength will be same. Now, density of the nucleus depends upon the mass number. No, density does not depend on the mass number. Radius of the nucleus is independent of the mass number. No, it is dependent on the mass number. That is, radius is proportional to 1 by 3, a raised to the power of 1 by 3. In exothermic fusion reaction, binding energy per nucleon of product nuclei is more than the reactant nuclei. Yes, this is the correct. So the correct answer for question number 2 is option number 4, right? Then coming to question number 3, when the jaw of a standard vernier are together, the sixth main scale division coincides with the sixth vernier scale division. All right, that is the main scale reading becomes your sixth. Then division. Then what is the zero error? Okay, they are asking for the zero error. So if we look into this diagram, what we find here is that the sixth main scale division coincides with the sixth vernier scale division. Now, if this is so, the zero error will be 6 main scale minus 6 vernier scale. So main scale minus vernier scale reading is nothing but the least count, which is equals to 0.1. So the zero error becomes 6 into 0.1 is equals to 0.6 millimeters. So here the correct answer will be your option number 4, right? Option number 4. And why positive? Because it is inside the zero of the main scale, right? So the correct answer for question number 3 will be option 4, right? Now question number 4. A certain mass of hydrogen is changed to helium by a process of fusion. The mass defect in fusion reaction is 0.02866 U. The energy liberated per U is given as 1 U is equals to 931 mega electron volt. So what they are asking is that the certain this changes into helium producer the mass. They are asking the mass defect. All right, they are asking the mass. No, they have given the mass defect, the energy liberated in U. Okay, they are asking energy liberated. What they are asking is the energy liberated. So if this is the mass defect, so if this is the mass defect, you simply multiply this with 931 as given in the question mega electron, you will get the answer. So simply multiplying 0.02866 with your 931 mega electron volt, the answer is equals to 6.675 mega electron volt, right? So the correct answer for your question number 4 is option 2, 6.675 mega electron volt. Simply multiplying with 931 will give you the answer. This quantity multiplied with 931 mega electron volt will give you 6.675 mega electron volt, right? Next comes your question number 5. The average binding energy per nucleon of the nucleus of atom is approximately equal to, right? So this you have to remember it, that it is equals to your 8 mega electron volts, right? It is approximately equals to 8 mega electron volts. Now question number 6. In vernier caliper, each main scale division is of 1 millimeter. Now, if 10 vernier scale division coincides with 9 main scale division, then the least count of the vernier caliper is, then it will be equals to 0.1 millimeter, right? So 0. Millimeter, na 0.1 millimeter, right? 0.1 millimeter. So how do we calculate it? To calculate the least count, see, value of one main scale division is 1 millimeter, right? Value of main scale division is 1 millimeter, and 10 vernier scale division is equals to 9 main scale division. It means one vernier scale division will be equals to 0.9, right? See, here 10 vernier scale divisions is equals to 9 main scale division, right? So your one vernier scale division will be equals to your 0.9 main scale division. And what is one main scale division? It is equals to 1 millimeter. It means one vernier scale division is equals to 0.9 millimeter, because one main scale division is equals to 1 millimeter. So 0.9 main scale division is equals to 0.9 millimeter, and least count is equals to main scale division value minus vernier scale division value, right? So main scale division value is 1 millimeter and vernier scale division is 0.9 millimeters. Subtracting them, it will give you 0.1 millimeter, right? So the least count for vernier caliper given over here is 0.1 millimeter, right? So now coming to question number 7. The ratio of the radii of lithium nuclei to F56 nuclei will be. So they are asking you the radius. Okay. So radius of a nuclei is, we know the formula, that is R is equals to R naught into A raised to the power of 1 by 3, right? So A raised to the power of 1 by T, where R is a constant and it is equals to 1.2 into 10 to the power of minus 15 meters, right? So since we have two A's, that is one A, that is A for lithium is 7 and that for ferrous is 56. So from here, using the formula, right, we can solve it and we get our answer as, so you'll get our answer as, let me calculate it first. See, the formula which we are going to use here is, that is your radius is equals to R naught into A raised to the power of 1 by 3. So if I write it like this, that radius of lithium upon radius of ferrous is equals to R naught into 7 raised to the power of 1 by 3 upon R naught into 56 raised to the power of 1 by 3, right? So this R naught and R naught cancels out. What we are left with is, let me write it here, what we are left with is R of lithium upon R of ferrous is equals to 7 upon 56 whole raised to the power of 1 by 3. So 7178, and cube root of 8 is 1 is 2, so it will become 1 by 2. So the ratio will be equals to 1 is to 2. So the correct answer is, ratio is equals to 1 is to 2. So the correct answer is option 4. So question number 7, the correct answer is option 4. Correct answer is option 4, right? Now coming to question number 8. Question number 8 says, if the observed reading OR is OR, correct reading is CR, zero error is ZE, and zero correction is ZC, then what will be the possibility? Means out of these four expressions, which of the expression is correct? So see, the correct reading is observed reading minus zero error, or zero correction is correct reading minus observed reading. So here The correct answer is your option number 4, right? Correct answer is option 4. Coming to question number 9, a lithium nuclei has, question number 9, lithium nuclei has 3 proton and 4 neutrons. If the mass of lithium nuclei is this much and mass of proton is this much and mass of neutron is this much, then mass defect of lithium nuclei in AMU is. How do we calculate mass defect? Mass defect is Z into mass of proton plus A minus Z into mass of neutron minus mass of the nucleus, right? This is how we calculate it. What is the formula? That is Z into mass of proton plus A minus Z into mass of neutron minus mass of nucleus, right? This is how we calculate the mass defect. So using that, here see, here is the formula for lithium. Mass Z is equals to your 3 and your A minus Z will be equals to 4. So there are 3 protons and 4 neutrons. So 3 into mass of proton plus 4 into mass of neutron minus the mass of the lithium nuclei. Solving this, we'll get mass defect as 0.040486, which is in your option 4. So the correct answer for this question is option 4, right? Now coming to question number 10. Question number 10 says that in a meter bridge experiment, a thin uniform wire AB of length 1 meter and uniform resistance X and a resistance of 12 ohm are connected. In the above question, after appropriate connections are made, it is found that no deflection takes place in the galvanometer when the sliding jockey touches the wire at a distance of 60 centimeter from A. Alright, what is the value of X? So according to them, the null point is your 60 centimeters. It means if the null point is 60, the L is equals to 60, then L minus 100 minus L will be equals to 40. So if the bridge is balanced, then 12 upon X is equals to 60 upon 40. So the 0 cancels out. 2 ones are 2, 3s are 2, 2s are 4, 2 3s are 6. Then 2 ones are 2, 3, 3 fours are 12. So your X is equals to, from this calculation, your X becomes equals to 8 ohm. So X is equals to 8 ohm. So the correct answer is option 1. Correct answer is option 1, right? So question number 10, the correct answer is option 1. Using the formula, using the concept P by Q is equals to R by S. For R we write L, for S we write 100 minus L, for P we are writing 12 and for Q we are writing X, right? So here using this we get our answer as option 1, that is 8 ohm. Now coming to question number 11. Question number 11 says that a nuclei which with mass number 240 breaks into two fragments each of mass 120. The binding energy per nucleon in the parent nuclei is 7.6 mega electron volt, while that of the daughter nuclei is 8.5 mega electron volt. The total gain in the binding energy of the process is. They are asking you to calculate the gain in the binding energy. So see, question number 11, right? So see, what they have done is, see, mass number of the reactant is 240, right? Mass number of the reactant is 240. So mass number at the reactant side and on the product side should be same. The binding energy of the binding energy per nucleon is 7.6 mega electron volt, that is for the parent nuclei. Then mass number of the product is 120 and the binding energy is 8.5 mega electron volt. So total gain in binding energy is equals to binding energy of the product minus binding energy of the reactant, because we know that the binding energy of the product end is more than the binding energy of the reactant side. So this binding energy which has been given here over here is binding energy per nucleon, right? Binding energy per nucleon. That is 8.5 mega electron mega electron volt for each nucleon. So at product side we have two particles. Each particles are having 120 nucleon, right? So 120 plus 120 into 8.5 minus 240 into 7.6. That is 240 we are taking common. We will get 8.5 minus 7.6, which is equals to 0.9. So 240 into 0.9 is equals to 216 mega electron volt. So this is the amount of extra energy over here. So what they are asking here is the total gain in the binding energy. This is your gain in the binding energy, and that is equals to 216 mega electron volt. So the correct answer for question number 11 is your option 1. Now, which of the following statements are incorrect? The first statement says that a nuclear force is much stronger than the Coulomb force acting between the charges, or the gravitational force acting between the masses. Okay, the nuclear force is much stronger. Yes, it is much stronger than Coulombian force. Then the nuclear force between the two nuclear force between two nucleons falls rapidly to zero as their distance is more than a few femtometers. Femtometer, right? Okay. Now this leads to the saturation of the force in the medium or large size nucleus, which is reason for the consistency of the binding energy per nucleon. So what we find is that both the statements is correct. So the correct answer for your question number 12 will be your option 3, that is both A and B are correct, right? The nuclear force is much stronger than the Coulomb force. Yes, this is because this is why the protons also being of the same size, same charge, although they repel each other, but their repellent force, which is the Coulomb force, is weaker as compared to the nuclear force, which binds the nucleons together. Although the nucleons are of same charge, but still their repulsive force is weaker as compared to the nuclear force, therefore they are bound together in the nucleus. The second statement says that the nuclear force between two nucleons falls rapidly to zero as their distance is more than a few femtometers. This leads to the saturation of the force in a medium or a large size nucleus, which is reason for the consistency. This is also true, right? So the correct answer for question number 12 is option 3. Coming to question number 13, in an experiment for a small angled prism, angle of prism A, the angle of minimum deviation delta varies with the refractive index of the prism as shown in the figure. Alright, so this is the diagram. First option is the point P correspond to refractive index is equals to 1, slope of the line PQ is equals to A by 2, and the slope is equals to 2A, none of the above statements. Right, so for a small angled prism, the angle of deviation is being given by the formula. Angle of deviation is given by the formula del is equals to your A into mu minus 1, right? So at point P, del is equals to 0. So if del is equals to 0, we will get A mu minus A. So from here we get A is equals to A mu, A cancels out. We get mu is equals to 1 at P. So at P we have mu is equals to 1. So correct statement is 1. Slope of line PQ is A by 2. From this we can say that if we are drawing refractive index on x-axis, see what we are getting the equation as is del is equals to A mu minus A. So comparing it is equals to y is equals to mx plus c. We get slope as A. So slope is not A by 2, right? The slope is not A by two, slope is A. So this statement is wrong. Second statement is wrong. The slope is neither 2A. Third statement is also wrong. So the correct answer for this question number 13 will be option 1, that is 0.2 correspond to the refractive index equals to 1. Now coming to question number 14. Question number 14. Question number 14 says pick out the incorrect statement from the following. Lighter elements are better moderators of nuclear reactors than heavier moderators. In a natural uranium reactor, heavy water is a preferred moderator to ordinary water. The mass energy interconversion takes place only in nuclear reaction and never in the chemical reaction. Cadmium rod are provided as reactors. So in this question we have to calculate incorrect statement. So mass energy interconversion takes place only in nuclear reaction and never in chemical reactions. This statement is incorrect because lighter elements are better moderators for nuclear reactors than heavier reactors. So this is correct because they are used to slow down the that neutron, high speed high energy neutron. So if a natural heavy water, yes, heavy water is preferred over normal water, and for this cadmium rod is provided in the reactors. This statement is also correct. So correct answer for question number 14 will be option 3. Let's see what they have given. They say a good moderator has two properties: it slows down the neutron by elastic collision and it does not remove them from the core. That is why the lighter elements are better. So the first statement is correct. Now heavy water is used in a reactor because it has a lower absorption probability of the neutrons than ordinary water. Okay, so second statement is correct. The mass defect, it takes place in the chemical process. However, is the mass defect involved in the chemical reaction are almost negligible than that in the nuclear reaction. So means the mass energy interconversion takes place in both nuclear reaction and chemical reactions both, but in chemical reaction it is very less, so it is negligible. So and but in statements 3 they say that it does not take place never in chemical reaction. So of the third statement is wrong. And cadmium rods are used for absorbing thermal neutrons and keeping chain nuclear reaction control. So option 4 is also right. So the incorrect statement among these four statements is your statement 3. So the correct answer for question number 14 is option 3. Coming to question number 15. Now question number 15 says in this question contains statement 1 and statement 2 from the four choices given after the statement. Choose the one that best describes the two statement. Okay, so it says that energy is released when heavy nuclei undergo fusion and undergo fission and lighter nuclei undergo fusion. Okay, this is true. Energy is released in both the cases. Second statement says that for heavy nuclei, binding energy per nucleon increases with increasing atomic number, while for the lighter nuclei it decreases with increasing z. It decreases. See, this second statement is wrong because for if we talk about binding energy per nucleon, it first increases and then decreases, right? It first increases and then decreases, because if you remember the graph, graph is like this, then we have some glitches, and then like this, and then like this, and here we have Fe, that is 56 atomic number. So up to 56 we can see that it's increasing in some or the other way, it is increasing, right? So for a lighter nuclear, as Z increases, at the binding energy per nucleon also increases, and as we are moving towards the heavier nucleus, the binding energy per nucleon is decreasing. But in this statement, it's just saying the opposite thing. What it says is that for a heavy nuclei, binding energy per nucleon increases, but from the graph we can say that is it decreasing, while for the lighter nucleus it decreases, and from the graph we see that it increases. Therefore, the correct second statement is incorrect. Let's see what they are saying in the options. They say statement 1 is false, statement 2 is true, no. Statement 1 is true, statement 2 is true, no. Statement 1 is true, statement 2 is true, no. Statement 1 is true, statement 2 is false. Yes. So the correct answer for question number 15 is option 4. Yes, the correct answer for question number 15 is option 4. Let's see, they have given graph. Yes, we have a graph over here also. From the graph we can see the atomic, as the atomic number is increasing in this direction, and the binding energy per nucleon is increasing in this direction. So for here is ferrous. So for approximately 56 atomic number, the binding energy per nucleon is increasing, somehow it is increasing, right? And then beyond 56 we can say that it is somewhat, it is decreasing in nature, right? Therefore for lighter nuclei, as the z increases, the binding energy per nucleon increases, and for heavier nuclei, as z increases, the binding energy per nucleon also decreases. As Z increases, binding energy per nucleon decreases for heavier nucleus. So statement 2 is incorrect. Now coming to question number 16. Question number 16. Question number 16 says that a VI curve of a PN junction diode is plotted as shown in the figure. For the plot, we can conclude that that the forward bias resistance of diode is very high. No, it is very less, almost infinite for the small values of the V, and after certain value it becomes very low. Right. The second statement says the reverse bias, the resistance of the diode is very high in the beginning up to a breakdown voltage. A breakdown voltage is not achieved. Yes. Now both forward and the reverse bias resistance are same. No. Both statement one no. So the correct answer for this question will be option 2. That is, in the reverse bias, the resistance of the diode is very high. We can see up to the breakdown, the resistance is very high and the current is very low. Current is very low because here we have current in microamperes, right? And then after the breakdown, the current abruptly increases to a maximum value. So the in the reverse bias, resistance of diode is very high in the beginning, but up to breakdown voltage is not achieved. So the correct answer for question number 16 is your option 2. The reverse bias, the n-type material is conducted to the positive negative. When the diode is reverse bias, the voltage of the cathode, therefore no current will flow. The ideal diode will act as a short circuit in the forward bias and open circuit in the reverse bias. Hence, the forward bias, the resistance of the ideal diode is 0, and in the reverse bias, the resistance of the ideal diode is infinite, right? So, here must be the misprint. The correct answer is option number 2. Option 2 is the correct answer, right? That is, for your reverse bias, the resistance is infinite, is almost infinite up to the breakdown voltage, right? Now, coming to question number 17. Question number 17 says that a helium nuclei can be produced by fusing two deuterium nuclei if the nuclear masses of the deuterium and helium are this and this respectively, then the energy liberated in the process is. So if we need to calculate the energy liberated, we need to calculate the mass defect. Now see, so mass defect can be calculated as 2 into mass of hydrogen deuterium minus 2 in mass of helium. That is, this is your reactant, this is your product, right? So from when we subtract this, energy related to your deuterium is this much, energy related to helium is this much. Subtracting this bracket is giving you what? Mass defect in U, and then we multiply with 931.5 electron volt, we get our answer as 25.24 electron volts. The correct answer for this question number 17 is option 2, that is 25.24, right? What simply we are doing here is we are just simply calculating the mass defect, that is mass of the reactants minus mass of the product will give you the mass defect, and this mass defect will be in AMU. So when one AMU corresponds to 931.5 electron volts, so this amount of AMU will result in an energy which will be this mass defect into 931.5 electron volts, and this would result in 25.24 electron volts. So the correct answer for question number 17 is option 2. Coming to question number 18. Question number 18 says, question number 18 says that assertion is in the process of nuclear fission, the fragment emits 2 or 3 neutrons as soon as they are formed and subsequently emit particles. Yes, this happens as the fragment contains an excess of neutron over proton. Emission of the neutrons and particle bring their neutrons proton ratio to a stable value. This is also correct. So both assertion and reasons are true, and the reason is the correct explanation for the assertion. So option 1 is correct. Option 1 is correct over here, right? Because see, the fission occurs when n by p ratio becomes greater than 1.5, right? It becomes more than 1.5. So when this ratio is disturbed, and this ratio disturbs because increasing the count of neutrons. So when the fission takes place, what is extra? Extra particles are the neutrons. So these neutrons are released, and because of this release of the neutrons, the n by p ratio of the nuclei stabilizes, and hence the nucleus, that's what is written in the reason, right? And hence the nucleus gets stable. So both assertion and reason are correct. So correct answer for question number 18 is option 1. Now question number 19. Coming to question number 19. Question number 19 says that a student in the experiment gets the following observation: reading for the bottom of an empty beaker is this much, that is this depth is being measured with the help of a microscope. Then reading of the bottom of the beaker when partially filled with liquid, again after filling it with liquid we get reading as 12.802. And then the reading of the liquid surface, we are taking the reading of the liquid surface, it is coming as 13.895. They are asking the refractive index. So when we subtract this 13 from this 13.895, we subtract the very first reading, we will get the real depth, that is real depth of the beaker. So real depth of the liquid, right? Real depth of the liquid, real depth of the liquid will be your, let me do it here, it's done here, right? See, the real depth will be equal to 13.895 minus 12.324. That is this quantity, that is the reading of the liquid surface minus reading of the bottom of the beaker will give you the real depth, right? And the reading of the liquid surface minus the reading of the liquid surface when partially filled with liquid. So first we are subtracting this quantity with this quantity, and then we are subtracting this quantity with this quantity to get the apparent depth. So now we have real depth upon real depth, and we have apparent depth, and the formula is refractive index of the liquid is equals to real depth upon apparent depth. So we have real depth and apparent depth, and dividing this we get our refractive index as 1.437. So the correct answer is option 4, that is 1.437. 1.437 is the correct answer over here, right? So now let's coming to question number 20. Question number 20 says that the energy of the reaction lithium plus proton gives 2 helium is the binding energy per nucleon of in lithium and helium nuclei are itna respectively. So they are asking the energy liberated. Again, energy liberated means mass defect into your 931.65 mega electron volt. So let's see what they have done. Is binding energy for nucleus is this much and binding energy per nucleon for helium is this much. So one lithium has 7 nucleons, right? And one helium has 4 nucleons. So if binding energy per nucleon for lithium is 5.6, so binding energy of lithium will be 5.6 into 7, and whereas for helium will be 7.06 into 4, right? So we have in the reaction we can see that we have 2 helium atoms. So 2 into 4 into 7.06, this gives the binding energy of the product side minus binding energy of the reactant side, that is 7 into 5.60, because we have only one helium atom. Difference of this will be equals to 17.28. So this is the correct answer. The 17.28 is rounded off as 17.3 mega electron volt. So the correct answer for question number 20 is option 1, right? Simply subtracting the binding energy of, not binding energy per nucleon, but binding energy of product minus binding energy of reactant. So calculating binding energy from binding energy per nucleon is binding energy into number of nucleons into the number of atom of it, right? So for helium we have 2 atoms, we are multiplying with 2, and the number of nucleon is 4, so we are multiplying with 4 also. In case of lithium we have only one lithium, so 1 into 7 into the binding energy per nucleon of lithium. So this gives you a correct answer for question number 20 as option 1. Coming to question number 21. Question number 21. Right. The question number 21 says the ratio of the nuclei density of two nuclei of mass this and this is. See, nuclei density is always equals to 1:1. Right. So correct answer is option 2. Now how it is equals to 1:1? See, density is equals to mass upon volume, and volume is equals to 4 by 3 pi r cube. So d1 upon d2 will be equals to 27 upon 64. 27 is the mass number of the first nuclei and 64 is the mass number of second nuclei. So mass upon volume. Now when it comes to volume, it is 4 by 3 pi r1 cube upon 4 by 3 pi r cube r2 cube. So it will turn out to be r2 minus r1 whole raised to the power of 2. It is, I tell you, r2 minus r2 upon r1 whole raised to the power of 3, right? Now R is equals to R naught into A raised to the power of 1 by 3, where R naught is constant. So D1 upon C, therefore your R2 upon R1, R2 upon R1 will be the ratio of the radius, right? So from here, see, D1 upon D2 is equals to, this is M1 upon M2 into A2 upon A1, right? That is the mass number and mass number of second nuclei upon mass number of the first nuclei. Why we are writing this? Because radius of any nuclei is directly proportional to its mass number, right? Directly proportional to the mass number raised to the power of 1 by 3. So instead of putting R2 upon R1, in place of R2 upon R1, what we can put? We can put A1, A2 upon A1 raised to the power of 1 by 3, and this 1 by 3 power and this cube cancels out, right? So we get 27 upon 64 into A2 upon A1. What is A2? A2 is 64. What is A1? A1 is 27. So cancelling out, we get 1 upon 1. So the density is equal to 1 is to 1, right? I hope this is clear to all. Now, next coming to question number, so correct answer of number 21 is option 2. That is 1 is to 1. Coming to question number 22, the following, the following wires are made of same materials with different length and diameters. Now, which of the following have the largest extension when the same tension is applied? All right. See, when the wires are being extended, the tensile strength has been, tensile force has been applied. So we are supposed to use over is the Young's modulus. So Young's modulus is equals to force upon area, which is stress, upon delta L upon L. So L comes here, right? Now the material for both the wires are same, right? Two wires, we have wires, are material is same. So for two different wires, if I say Y is same, then F is also same. Let A is A1, L is L1, delta L1 is also L1, right? Different length and different. Okay. Now what we get from here is, we can say if this is equals to F upon L2 upon A2 into delta L2, right? So we need to find the extension. We are talking about the extension, right? So if we write extension as, we write delta L is equals to, your delta L will be equals to F L upon A into Y, right? Now F is constant, Y is also fixed or constant over here. So from here we can say that delta L is directly proportional to L by A ratio, where A is the area of cross section and area of cross section is given by pi r square. Now R can be written as pi d by 2 whole square. This is area of cross section. This is also area of cross section. So from here we can say that area of cross section is directly proportional to D. So in place of A we can write D. So from what here we get is, your delta L is proportional to L by D. So extension will be more for the wire which has L by D ratio as maximum. So for first wire we find L by D ratio, D square ratio. So L by D square ratio for the first wire is 5 into 10 to the power of 3. For the second wire it comes as 20 into 10 to the power of 3. For the third wire it comes as 3.3 into 10 to the power of 3, and that for the fourth wire it comes as 10 into 10 to the power of 3. So we find that L by D square ratio is maximum for second wire. Therefore, the extension in the second wire will be maximum. So the correct answer for question number 22 will be option 2. I hope this is clear to all. What we are doing here is that we have formula Y is equals to F into L into delta A into delta L. From here we can say that your delta L is equals to F into L upon A into Y. From here we can say what? That is your delta L is proportional to L upon A, and in place of A we can write D square. So for whichever wire the ratio of L upon D square is maximum, that wire will have its maximum what? Extension, right? Next, coming to question number 23. Yes, question number 23. Question number 23 says that a uranium, that is 23592 fusion reaction produces 200 mega electron volts. The amount of uranium required to run 100 megawatt nuclear power plant for a day with 100% efficiency is. They are asking you the mass of the uranium required. So if single uranium produces this much energy, we have to calculate the number of particles of the uranium used, and from number of particles we can calculate the number of moles, and from number of moles we can calculate the mass. So amount of energy to be produced can be calculated by the power to be produced into time. So see, first thing is 1 electron volt is 1.6 10 to the power of minus 19 joule, right? So your joule is watt second. Now energy required is 100 mega. 100 megawatt means 100 into 10 to the power of 6. This is energy into time. Time is 24 hours, into 60 will convert it into minutes, and into 60 will convert it into seconds. So multiplying this, we will get 864 into 10 to the power of 864 into 10 to the power of 10. Yeah, 10 to the power of 10. Yes, 860 into 10 to the power of 10 to the power of 10. Wait a minute. Huh. 10 to the power of 10 joules. Now this is the total energy which we require in one day. Now if this is the energy we require in one day, and the amount of energy which we have calculated is in joule. Now if we need to convert it into electron volt, we'll divide it by 1.6 10 to the power of minus 19. So this will give you 540 into 10 to the power of 29 electron volts. So total energy required to run the power plant for one day is 540 into 10 to the power of 29 electron volts. Now this is the total amount of energy required. Now one atom releases 200 mega electron volts. So if we divide the energy of total energy required by energy of one atom, we'll get the total number of atoms. So dividing 540 into 10 to the power of 29 electron volts by 200 10 to the power of 200 into 10 to the power of 6 electron volts give you 2.7 into 10 to the power of 10 to the power of 23 atoms, right? So the number of atoms of uranium required is 2.7 into 10 to the power of 23 atoms. Now the number of moles, if we divide the number of moles with the Avogadro number, we'll get the number of moles, and then when number of moles multiplied with mass number of the uranium, we get the mass. So we get mass as 0.1 kg, or you can say 105.3 grams, 105.3 grams. The answer is given in kilograms, so it is approximated as 0.1 kilogram. So the correct answer for question number 23 is option 3, right? So I again repeated that one atom produces 200 mega electron volt. This is the energy. Now 100 megawatt is the power of the power plant. So to calculate energy, we'll multiply 100 megawatt watt with the time, that is 24 into 60 into 60, which is in seconds. That will give you energy in joules. Then after calculating energy in joules, we'll divide it by 1.6 10 to the power of minus 19 to get our energy which is in joule in electron volt. Now once we have the energy in electron volt, this is the total energy which is required to run the power station for one day with 100% efficiency, right? Now this energy when divided by energy of one atom will give you the number of atoms required in one day. Now number of atoms when divided by the Avogadro number will give you the number of moles of uranium required to run the power plant for one day. And when this number of moles multiplied with the mass number of uranium will give you the mass of the uranium required to run the power plant for 1 day with 100% efficiency, and that mass is 0.1 kilograms. That is around 100 grams uranium will help you to run the power station of 100 megawatt for 1 day with 100% efficiency, right? Now coming to question number 24. Now in question number 24, it says that the heavy water is used as a moderator in a nuclear reactor. The function of the moderator is to control the energy released in the reactor, to absorb neutrons and stop chain reaction, to cool the reactor faster, or to slow down the neutrons to thermal energy. See, the function, main function of the moderator is to slow down the neutrons, right? To control the energy released by the reactor, it cannot be controlled by the reactors, right? To absorb neutrons, if it will absorb the neutron and stop the chain reaction, then what's the use of the nuclear reactor? So this is also not correct. Then to cool the reactor faster, no, we do not need to cool the reactors, we simply need to slow down the neutrons to thermal energy, right? So this is the correct answer. Is question number 24, the correct answer is option 4, right? Question number 24, the correct answer is option 4. Now coming to question number 25. Question number 25 says that a student in experiment with resonance tube, resonance tube, an apparatus in the physics lab to find the speed of the sound at room temperature. He got resonating length of the air column as 17 centimeter and 51 centimeter using the tuning fork of frequency 512 hertz. Find speed of the sound at room temperature and specify whether the side water reservoir was moved upward or downwards to obtain the second resonance, that is at 51 centimeter. So see, in the diagram, with the help of the diagram, we can see that, see, first thing is the resonating tube. The instrument which is they are using here is student experiment resonance sounds and apparatus, right? So the resonating tube which they are using is this is the resonating tube, and the resonance tube is considered to be an open organ pipe, right? It is taken as open organ pipe. So when the disturbance has been given, you can see that here at this open end we get an antinode, and here we get node, and then this also is an open, so we should get antinode, right? Because it's an open pipe, so at both the ends we will get antinode, so we'll get an node in between. Now if this is the case, if this is the case, then length of the, see, then length of the organ pipe is equals to, or the length of the air column which is vibrating is equals to quarter of the wavelength, because this will be equals to half of the wavelength. This is half of the wave, this will be half of the wavelength, and this length will be equals to quarter of, that is lambda by 4. So 17 is equals to lambda by 4, right? We have not done it like this. See, we can say that 17 is equals to lambda by 4. So we'll get lambda is equals to 68 centimeter, or you can say lambda is equals to 0.68 meter. Now once we have lambda and we have frequency as 512, so multiplying frequency with lambda will give you the speed, that is equals to 348 meter per second, right? So simply from, if we know that the organ pipe which we are using here is an open organ pipe, and for an organ or open organ pipe we have what, we have our length of the organ pipe is equals to lambda by 4. So we have length as 17, so from there we'll get lambda, and from lambda we can easily calculate the velocity. Now see, since the air column here is 17 and then in the third, in the second resonance place it is 51, so definitely we have to move the water downwards. So the correct answer will be equals to, your first answer is 348 meter per second, and second answer will be that reservoir has to move downwards. So the correct answer is your option 1. Yes, option 1. So correct answer is option 1, that is question number 25. The correct answer is option 1. Now coming to question number 26. 26. So question number 26 says that when two nuclei with A is equals to 8, means two nuclei with having mass number as atomic mass as 8 joined to form a heavier nucleus. The binding energy per nucleon of the heavier nuclei is more than the binding energy per nucleon of the lighter nuclei, same as the binding energy per nucleon of the lighter nuclei, less than the binding energy per nucleon of the lighter nuclei, double as the binding energy per nucleon of the lighter nuclei. See, the energy at the product side is more than the energy at the reactant side. Therefore, the energy will be more, the binding energy per nucleon will be more for the heavier nuclei as compared to the lighter. So, the correct answer is option 1, that is more than the binding energy, that is the says that the binding energy per nucleon on the heavier nucleus is formed at the product side, because here what is happening is the fusion, that is two nucleus are combining to form a single nucleus, therefore here fusion is taking place. So at the product side we have a heavier nucleus, and at the product side we have the binding energy greater. So the binding energy per nucleon for the heavier nucleus will be more than the binding energy per nucleons of the lighter nuclei. So the correct answer for question number 26 is option 1. So now coming to question number 27. Question number 27 says that the order of the magnitude or density of the nuclear matter is 10 to the power of 17 kg per meter cube. This again you have to remember, that is the order is 10 to the power of 17 kg per meter cube. How, from where it comes? It comes from this calculation, right? Substituting the values. Just simply remember that the order of the density is 10 to the power of 17. That is enough. Now coming to question number 28. Question number 28 says that in an experiment, balancing moment, alright, balancing a moment, experiment of balancing moment, suppose the fulcrum is at 60 centimeter mass and a known mass of 2 kg is used at the larger on the longer arm. The greatest mass of M, which can balance against 2 kilograms, such that the minimum distance of either of the masses from the fulcrum is least 10 centimeter. See, the greatest mass will use, if it is the balancing condition, the greatest mass will use the least distance, right? And the smallest mass will use the maximum distance. So smallest mass is your 2 kg and the distance maximum is equals to 60, because it has to be on the longer side, and the maximum mass is m and the shortest distance is 10. Oh, shortest distance is 10. Let me write it here. So your 2 into 60, that is smallest mass with longest length, is equals to maximum mass into least length, right? This is what is principle of moment of force. Principle of moment of force means clockwise movement is equals to anti-clockwise movement in the balancing condition, right? So this 0 goes off with this 0, and what we are getting with is m is equals to 12 kg. So the correct answer for question number 28 is your option 1, which is equals to 12 kg. Again, the basic thing over here is you should know the principle of moment of force. For the balancing condition, torque of one side will be equals to torque on the other side, that is anti-clockwise will be equals to clockwise. Second thing which you should know is, if we are using the minimum mass, the length should be maximum, that is 60, and if we are using maximum, that is the greatest mass m, then the length should be the least, that is 10. Using this we solve it and we get mass as m as 12 kilograms, right? Then coming to question number 29. Question number 29 says that the dependence of the binding energy per nucleon Vn on the mass number A is represented by, we have seen the graph, that is first abruptly increases for a certain mass number and then it gradually decreases. So it first increases and then decreases, and this is the graph which will represent the binding energy graph of the atoms. So the correct answer for this question will be is option 1, and the question is question number 29. So the correct answer for question number 29 is option 1. Question number 29 is option 1, right? Now then comes your question number 29 is option 1. So question number 30. right? Coming to question number 30, the question number 30 says if the binding energy of the electrons in a hydrogen atom is 13.6 electron volt, the energy required to remove the electrons from the first excited state of lithium. So see, the very first thing is for first excited state of lithium, your N will be equals to 2, right? Because we are supposed to remove from the first excited state. First excited state means L is equals lithium plus, right? And we have to make it plus 2. Second thing is the formula is 13.6 into Z square upon N square, right? Z square upon N square. We can see the calculations over here. N will be equals to 2 for lithium first excited state, and the formula is 13.6 into Z square upon N square electron volt. So we have E is equals to 13.6 into Z is your, for lithium it is 3, so 3 square upon N is equals to 2, so N square, so we get 13.6 into 9 upon 4, and multiplying with this we'll get 30.6 electron volt. So the correct answer for question number 30 is option 1, right? Option 1 is the correct. This is directly formula based question, no tricky, no simple, straightforward question. So in question number 31, it comes in a fusion process. In a fusion process, nuclei A divides. Yeah, sorry, it's fission. In a fission process, nucleus A divides into two nuclei B and C. Their binding energies being EA, EB, and EC respectively. Then the binding energy on the product side is always greater than the binding energy on the binding energy on the reactant side, right? So binding energy of the product side is equals to binding energy of binding energy of B plus binding energy of C. That is EB plus EC should be greater than EA. So the correct answer is option 2. Correct answer for question number 31 is option 2. Again, the same concept that the binding energy at the product side will always be greater than the binding energy at the reactant side, right? So question number 32. Question number 32 says there are two capillaries of the same material but of different radii are dipped in a liquid. In one of the capillary, the liquid rises to a height of 22 centimeter, and in the other by 66 centimeter. The ratio of the radii is. Again, this is directly formula based question. For a capillary, the height attained by the capillary, the liquid, the height attained by the liquid is given as h is equals to 2t cos theta upon r dg, right? R dg, where r is the radius of the what R is the radius of the capillary, D is the density of the liquid, and G is the acceleration due to gravity, and T is the surface tension. Because the liquid are the same and the material of the capillary is also same, so T and your D and G are constant. So what we conclude from here is that H is inversely proportional to R. H is inversely proportional to R. So H1 upon H2 will be equals to R2 upon R1. H1 upon H2 will be equals to R2 upon R1. So what they have given in the question is H1 and H2 are 22 and 6. So we need to calculate is the ratio of the radius. So we need to calculate R1 upon R2, and that will be equals to H2 upon H1, and that will be equals to 66 upon 22, and this will be equals to 3:1. 66 upon 22 will be equals to 66 upon 22 will give you 3 upon 1. So ratio will be 3:1. Do we have it? Yes, we have it in option number 3. So the correct answer is option 3. Again, direct formula based question. What is the formula they have used over here? Let me write it here, that H is equals to 2t cos theta upon R dg. H is the height of the liquid ascent, that is the height with the liquid ascent. T is the surface tension, cos theta is the angle of contact. Sorry. R is the radius of the capillary, D is the density of the liquid, and G is the acceleration due to gravity, right? And using this formula, we find that H is inversely proportional to R, that is the radius of the capillary. Using this concept, we get the formula for question. We get the answer for question number 32 as 3:1. Now coming to question number 33. Question number 33 says that if the radius of aluminium is 3.6 Fermi, the approximate nuclear radii of copper in Fermi is. Okay. So again here we will be using the formula R is equals to R naught into A raised to the power of 1 by 3. So radius of aluminium, तो इधर लिखते हैं, we write it here that the radius इधर है ना 33. So radius of aluminium here, radius of aluminium upon radius of your copper, radius of copper will be equals to atomic number of aluminium raised to the power of 1 by 3 upon atomic number of copper raised to the power of 1 by 3. This is the thing, right? So from here we can say that your 3.6 upon radius of copper is equals to your 64 and aluminum is 27, right? So 27 upon 64 whole raised to the power of 1 by 3. So this will result in your 3.6 upon radius of copper is equals to 27 का cube root is 3 and 64 का cube root is 4. So this comes as 3.1, this becomes 1.2 and this, so we get radius of copper as 2.8 Fermi, right? So 2.8 Fermi, sorry 2.8 thing, 12 into 4 is 4.8, right? 12 4s are 48. So radius will be 4.8 Fermi. So do we have it? Yes, we have it in option number 1 itself. So the correct answer for question number 33 is 1. That is 4.8 will be the Fermi. 4.8 Fermi will be the radius of the copper, right? Copper. Now coming to question number 34. Question number 34 says that the binding energy of the nuclei X and Y are E1 and E2 respectively. Two atoms of X fuse to give one atom of Y. The energy Q is released. Then again why the product का binding energy will be greater than the reactant का binding energy. So difference of that will give you the energy released. So we have 2x giving you 1 y. So y की energy is E2. So E2 minus 2 times of E1 will give you 2. So the correct answer is option 2. That is E2 minus 2 times of E1 is the amount of energy liberated in this reaction. So the correct answer is option 2. The correct answer for question number 34 is option 2. Yes, option 2. Right. Now coming to question number 35. Question number 35 gives you, question 35 says, question 35 says that IV graph of two different electrical appliances P and Q are shown in the diagram, and the resistance RP and RQ are the resistances of the two devices. Then they are asking you to compare the resistance. This is IV curve, means y-axis is your current and x-axis is your voltage, means slope will give you I upon V, which is equals to conductance, that is G. But we need here is resistance. So reciprocal of slope will be equals to resistance. Greater is the slope, lesser will be the resistance. Lesser is the slope, greater will be the resistance. So P has a lesser slope, so P resistance will be more. So RP is greater than RQ. So the correct answer for question number 35 is your option 2. Correct answer is option 2, right? So the correct answer is here 2A. And what is the concept? That the slope of this IV curve will give you conductance. So reciprocal of the slope is resistance. So lesser is the slope, lesser is the conductance, means more is the resistance. So resistance of the appliance P is more as compared to the resistance of appliance Q. Now coming to question number 36. Question number 36 says that in any fission process, the ratio mass of fusion particle upon mass of parent nuclei is, it is fission, that is in any fission process, the ratio, किसका ratio, the mass of the fission products, the final product है, and a mass of the parent nuclei. So is always mass na, so it always less than 1. Why less than 1? Because there will be some mass defects, and that some mass defect will be, that lost mass will be converted into energy, and because that lost mass is converted into energy, therefore this ratio, that is mass of the product will be less than the mass of the parent, because mass is lost in energy, therefore numerator is less than the denominator and the factor will have a value less than 1. So the correct answer is option number 1. So question number 36, the correct answer, question number 36, the correct answer is your option 1, right? Correct answer is option 1. Now coming to question number 37. Question number 37 says that choose the correct statement. The nuclear force becomes stronger if the nucleus contains too many protons compared to the neutrons. The nuclear force becomes stronger if the nucleus contains too many neutrons compared to proton. Nuclei which atomic number less than 82 show the tendency of degeneration. Less than 82. The nuclear force becomes weak if the nucleons contain a large number of nucleons. See, the stability of nucleus is widely dependent on the ratio of number of neutrons upon number of protons, right? So the nuclear force cannot be simply decided by the amount of protons contained into it or number of neutrons contained into it, right? So these two statements are not correct. Coming to the third statement, the nuclear atomic number, the atoms below the atomic number of 56, that is for iron, ferrous, are stable. So this statement is wrong because it says that the nuclei with atomic number less than 82 are unstable. They have the tendency of degeneration. So it is absolutely wrong. So what we are left with is option 4, that is the nuclear force becomes weak if the nucleus contain larger number of nucleons. So if a nucleus contain a larger number of nucleons, definitely its mass number is getting higher and higher, and for the higher mass number of nuclei of higher mass number are more likely to be unstable. Therefore, the correct statement is option 4. Question number 37, the correct answer is option number 4. Coming to question number 38. Question number 38 says that inside a nucleus, if nuclear force between two protons and between a proton and a neutron are FPP and FPN respectively, then C. Nuclear force is independent of the nature of the charges. It is nowhere dependent on the Columbian force. Therefore, the nuclear force for all the nucleons is same, because it is nothing but the binding force. So, if it is same, the correct answer for question number 38 will be what? Option 3. Question number 38 will be option 3. Let's see what they have written here is the nuclear force are charge independent and always attractive, right? They are charge independent. Now, so the nuclear force between the two protons, a proton and a neutron or a two neutrons will be the same. So, or whether whatever be the nucleons, or for all nucleons, the nuclear force is same. So, the question number 38 will hold its correct answer as option number 3. Coming to question number 39. Question number 39 says that two known to know the resistance G of a galvanometer of a half deflection method, a battery of EMF V and resistance R is used to deflect the galvanometer by an angle theta. If a shunt is of resistance S is needed to get half deflection, then G, R and S are related as in the question. Okay. Now see, what is done over here is, for a full deflection current, the full deflection current for a galvanometer Ig will be equals to your V upon R plus G, right? R is the resistance which is being connected to the galvanometer, right? This is the full scale deflection current. Now, when a shunt is being connected to it, this current Ig becomes Ig dash, and this is equals to your V upon R plus G S upon G plus S, because shunt is connected in parallel to the galvanometer, and using the formula, what formula? That is for a parallel, R1 into R2 upon R1 plus R2 is the R equivalent. for two resistances connected in parallel. So R1 is G, R2 is S. So we get this as IG, IG dash, or you can say this is I, the current which is flowing when the shunt is being connected, right? Now, when the shunt has been connected and we use it as a voltmeter, what we see is that, ammeter, we will get I G dash, let this be I, yeah, this will be I, let this be I G dash into G will be equals to I minus IG dash, I minus IG dash into S, right? I minus IG dash into S. So if we rearrange it, we'll get I G dash into G plus S is equals to I into S, right? IG dash is equals to G plus S into I S. This is S. Now what is IG dash? IG dash is equals to I into S upon G plus S. So from here we get Ig dash as I into S upon G plus S. And what we have as I? We have I as this. We have I as this. So when we put I here, we get I G dash is equals to this quantity placed over here, right? And what is Ig dash? Ig dash is half deflection current. So what is full deflection current? Full deflection current is this. So half of this, that is, we multiply this with 2 and then this quantity becomes Ig dash. So finally what we are left with is, I'm writing here, what we are left with is V upon 2R plus G, right? What is this? This is Ig dash, which is half of Ig, is equals to I, which is V upon R plus Gs upon G plus S into S upon G plus S. So when you solve this, the final which we get is your option 2, that is S into R plus G is equals to Rg, right? So the main things which we have to remember for solving this is, I'm telling you, the main equations which we are supposed to use here are, first is this one, that is Ig is V upon R plus G, that is for the galvanometer without shunt. Now when shunt is connected, the equivalent resistance is equals to Gs upon G plus F, and for that case the full scale deflection current I will be equals, this is full scale deflection current when shunt has been connected, that is I is equals to V upon R plus Gs upon G plus S, right? This is full scale deflection current when shunt is connected. Now for this is the equation which we use or we write when a galvanometer is converted into an ammeter using a shunt. So this is the expression, that is voltage drop across the galvanometer resistance is equals to voltage drop across the shunt, because both are connected in parallel. Now in this, when we rearrange it, Ig dash into S goes this side, we get Ig dash into G plus S is equals to I into S. S is not written over here. I into S, right? I into S. So we get Ig dash, and now when G plus S comes this side, we get Ig dash is equals to I into S upon G plus S. Ig dash is equals to I into S upon G plus S. Now what is Ig dash? Ig dash is the half scale deflection current. So if full scale deflection current was Ig, then Ig dash will be equals to Ig by 2. So we have written as Ig by 2 into I into S upon G plus S. Now putting the value of Ig here, we get V upon 2R plus G. Putting the value of I, we get V upon R plus GS upon G plus S into S upon G plus S. Solving this, we finally come to this, right? If you solve this, this is the final main expression which is to be solved. Solving this, we will come to this expression. So the correct answer of number 39 is option 2, right? Now coming to question number 40. Question number 40 says that in a thermal fusion, which statement is incorrect? Energy is provided by raising the temperature. No, खुद ही exothermic है. 2. Energy must be provided to overcome Colombian repulsion between approaching positive charges. See, the Colombian force is very less, or it is, you can say, negligible in case of nuclear forces. So this is not to be considered. Now the third option says that it is responsible for the formation of the red giant stars. Yes, in this reaction can be explained for the use for to explain the formation of the giant star. Question and the fourth option says that a required temperature of the order of 10 to the power of 8 Kelvin. No, this is also not correct. So the correct answer is option number 3. So the correct answer of question number 40 is option 3, right? Now coming to question number 41. Question number 41. Question number 41 says that considering the efficient functioning of a nuclear reactor, which of the following statement is incorrect? Is the statement incorrect, right? So incorrect here. The moderator slows down the fast neutron released by the fusion reaction while elastic scattering. सही है. It's correct. The core of the nuclear reactor is surrounded with the reflectors to prevent leakage. Yes. Heavy water is used as a moderator in fast breed reactors that use plutonium 239 as fuel. The average 2.5 neutrons are released per fission in uranium. This is average is because in some it releases 2 and in some it releases 3. So average of 2 and 3 is 2.5. So this is correct, this is correct, and this is correct, and I'm doubtful of this, but because all the three are correct, so this is definitely wrong. So this statement is wrong. Let me see what they are saying here is, in some of the reactions 2 neutrons are emitted while in some 3 are emitted, therefore the average is 2.5 neutrons per fusion, right? So your fourth statement is correct. Now these neutrons use unless slow down will escape from the reactor without interacting with the uranium nuclei. Therefore, the moderators are produced to slow down the thermal neutrons while elastic collision. So the first statement is correct. However, the fast breed reactor use fast neutrons for sustaining the nuclear reactors. Hence, the moderator are not required. Therefore, because in the fast breed reactors, moderators are not required, so there is no role of heavy water. Therefore, third option is wrong, right? So see, you can eliminate the options and get the correct answer. Even if you have some confusion, if you don't know the answer, if you read this question and eliminate the incorrect options, you will get to the correct option, right? So it's not always that you know answer of all the questions, right? So question number 42 says that in a Vernier caliper has 50 divisions which coincides with 49 main scale divisions, right? It means your 50 Vernier scale division, 50 Vernier scale division is equals to your 49 main scale division. It means one Vernier scale division is equals to 49 upon 50 main scale division, right? And what they say, if each main scale division is 0.5 millimeter, then the minimum inaccuracy in the measurement of the capillary is, so one main scale division is 0.5 millimeter. It means one Vernier scale division is equals to 49 upon 50 into 0.5, right? This comes this becomes 10, 0.49. So it says that one Vernier scale division, yeah, one Vernier scale division is equals to 0.49 millimeter. So least count is equals to mean scale division value minus Vernier scale division value. So one main scale division is 0.5 millimeter and one Vernier scale is 0.49 millimeter. So the least count becomes 0.01 millimeter. So the correct answer is your option 0.01 millimeter, and that is option 3. Right? Again, always the calculation is same. That is number of Vernier scale divisions equals to number of main scale division. From there you get the how much is one Vernier scale division equals to how many main scale divisions. Then you multiply that number with value of one main scale division. You will get the value of one Vernier scale division, and subtracting the value of one main scale division minus value of one Vernier scale division will give you the least count, right? So question number 42 has option 3 as its correct answer. Now question number 43. Question number 43 says that the energy of 24.6 electron volt is required to remove one of the electron from a neutral helium. The energy in electron volt required to remove both the electrons. Okay. Now we are removing both the electrons. It means N will be equals to 1 over here, and your Z of for the helium. Here is the question. We will use the equation that is 13.6 into Z square upon N square, right? Z square upon N square. Z is equals to 2 and N will be equals to 1. Putting the values, we get it as 54.4 electron volts. So the correct answer for question number 43. Acha. So for one of the second, for a second electron, it is 54.4 electron volt, and for the first it was 24.6 electron volt. Adding both will get 79 electron volts. So the energy required to remove both the electrons, they are asking you the energy required to remove both the electrons from the nuclei of the helium. So it is equals to 79 electron volts, right? So the correct answer for question number 43 is option 4. So coming to the next question, and the next question is your question number 43 is done. Question number 44. Now question number 44 says the screw gauge has a pitch of 1 millimeter and 50 divisions on the circular scale. Screw gauge B has a pitch of 0.5 millimeter and 100 divisions on the circular scale. If least count, then the possibility is true. See, the least count for a screw gauge is given as your pitch upon number of circular scale division. So if we see from this, we will get pitch, that is for A, least count for A will be equals to your 2 upon 100, which is equals to 0.02 millimeter, right? And that is for least count for B will be equals to 0.01 millimeter. So we can see that least count for A is your 0.5 upon 0.05. Yes, 0.05. So we can say that least count for your A is 4 times the least count of B. So least count for A is equals to 0.4 times of least count of B. So the correct answer for question 44 is equals to option 2. Yes. Least count is pitch upon number of divisions. So for A it comes as 0.02 and for B it comes as 0.005. So we get least count for A is equals to 4 times the least count of B. Now coming to question number 45. Question number 45 says that a nucleus at rest splits into two nuclei, fission, which moves with the speed of v and 27v. The ratio of the radii of the two nuclei will be respectively. Okay. So for this you see, according to the question, both fragments are generated from the same nucleus, so their density will be equal. Okay, density is equal. Now we know that mass is equals to volume into density. Since density are equal, so the mass of the fragments are in the ratio of the volume, right? Now, so m1 upon m2 will be equals to v1 upon v2. m1 upon m2 will be equals to v1 upon v2, and volume is directly proportional to r cube, so r1 upon r2 whole cube. So we get V1 is equals to V and V2 is equals to 2 times 2V, 27V. This is the velocities. They are giving the velocities, right? Now we know that from the conservation of momentum, that is, if the they say the nucleus is at rest and finally it is splitting into two nuclei. So initially the particle was at rest. So the two particles which we are getting will have a momentum that will be equal in magnitude, but they will be opposite in direction. Therefore, we can from here say that is m1 into v1 is equals to m2 into v2, and from here putting the value of v1 and v2, we get m1 is equals to 27 times of m2, right? M1 is equals to 27 times of M2, that is M1 upon M2 is equals to 27 upon 1, and M1 upon M2 is equals to R1 upon R2 whole raised to the power of 1 whole raised to the power of 3. So from here we get R1 upon R2 is equals to 3 upon 1. Therefore, the correct answer for question number 45 will be equals to option 1, right? Question number 45, correct answer is option 1. 45, option 1. Yes, 45 is option 1, right? Again, basic thing is here the mass is directly proportional to with the volume because density is same. So m1 is upon m2 is equals to v1 upon v2, and v1 upon v2 volume r1 upon r2 whole raised to the power of 3, right? Because volume is 4 by 3 pi r cube. So volume is directly proportional to r cube. So we have, and because of law of conservation of momentum, m1 into v1 is equals to m2 into v2. v1 is v and v2 is 27v. From here we get m1 upon m2 as this quantity comes as 27. So when this quantity comes as 27, this r1 upon r2 comes as 3 is to 1, right? So the correct answer is option number 1. 46, question number 46 says that if the time period of an undamped oscillation is t and that of the damped oscillation is t dash, then what is the relation between t and t dash? See, for a damped oscillation, time period is more, so t dash is greater than t. Do we have it? Yes, we have it on option number 4. So option number 4, question number 46. Question number 46. Yes. Question 46, the correct answer is option 4, that is t dash is greater than t. That is the time period for a damped oscillation is more than the time period for a undamped oscillation, right? Because in damped oscillation, the moment of inertia also comes, so the numerator becomes greater, and the numerator becomes more, t time period becomes more. So coming to question number 27, 47, sorry, 47. So 47 says that sorry, in a nuclear fusion process, the mass of the nuclear fusion process, the mass of the fusing nuclei be m1 and m2, and that mass of the resultant nucleus be m3. Then m1 plus m2 will be less than m3. m3 is final product. The mass of the reactant side will be less than the mass of the product side because of the mass energy conversion. So it is fusion. So m3 will be less than m1 plus m2. So m3 is less than m1 plus m2 is your option 3. So the correct answer is option 3, right? Why? Because in this reaction, the mass is converted into energy, so the mass of the product will be less than the mass of the reactant. Mass of product is m3 and mass of the reactant is m1 plus m2. So m3 is less than m1 plus m2, which is in your option 3, right? Now coming to question number 48. Question number 48. Question number 48 says that the mass of lithium nucleus is this much less than the sum of the mass of its all nuclei. Means they have given you the mass defect over here. This quantity is mass defect. The binding energy per nucleon for this is, so binding energy first if we calculate the binding, this is the mass defect. So we have mass defect. So mass defect is 0.042 U. Now 0.042 U when multiplied with 931.5 will give you the, this is the binding energy, this product will give you binding energy, and then binding energy upon 7 will give you your answer, because they are asking you binding energy per nucleon. So multiplying this, let me see, multiplying this will give you 39.123, and 39.123 when divided by 7, 39.123 when divided by 7 will give you 5.6 mega electron volt, and 5.6 mega electron volt is option 2. So the correct answer is option 2. I repeat, this quantity is mass defect. When mass defect multiplied with 931.5, 931.5, then you will get the binding energy, but they are asking you binding energy per nucleon. So lithium has 7 nucleons, so we divided by 7 and we get our answer as 5.6 mega electron volt. That is option 2 for question number 48. Coming to question number 49, in a usual Vernier 39 Vernier scale division coincides with, sorry, 9 Vernier scale divisions coincide with 8 mean scale divisions, then what is the least count? Again the same method. What? 9 Vernier scale divisions is equals to 8 mean scale division. So 1 Vernier scale division is equals to 8 by 9 mean scale division. So value of 1 Vernier scale division will be equals to 8 by 9 into mean scale division. Value of mean scale division. We don't know value of mean scale division. Not given over here. So this is the thing. What is least count? Least count is value of 1 main scale division minus 1 Vernier scale division. So we have 1 main scale division minus 8 by 9 main scale division. So we will get what? 1 upon 9 main scale division. So if one division is 1 millimeter, it will be 9 by 1 millimeter. So they have not given whether it is a millimeter or not, but we have 1 by 9 over here. So the correct answer for question number 49 is option 2. Yes. Yes, we have 1 by 9 is the least count, right? It will be in millimeters. Then comes the question number 50. Question number 50 says that if M having mass number A and Z, MP and Mn denotes the mass number of the nuclei, proton and neutron respectively in units of U, then the binding energy represent it, binding energy represent its binding energy in mega electron volt is, then so this, okay, so see, इधर ही देख लो, mass defect is equals to number of protons into mass of proton plus number of neutrons into mass of neutron into mass of nucleus. अब इस mass of nucleus को इधर कर दो and delta m को इधर कर दो, and what is delta m? Delta m into c square is equals to binding energy. So delta m will be equals to binding energy upon c square. So binding energy upon c square can be written in place of delta m. So here we have delta m. So what we get? We get m of A, that is mass of the nucleus, is equals to mass of proton plus mass of neutrons minus binding energy upon c square. So this is in your option 2. So the correct answer is option 2, right? So this is how we get answer 2 as the correct answer for your question number 50. So we have discussed all the questions. So I hope the explanation for each and every question is clear to all. If you have any doubt, any problem, please comment in the comment box so that we can rectify the problems, right? And this is all for this question paper. Have a great day. Thank you. That is all from my side. Thank you.